pleasure to hear from the esteemed speakers for the day. We have two esteemed speakers for the day. Let me introduce the esteemed speakers to you. Our first speaker is Mr. Abhijit Masatiwar, who is Engineering Manager at ZS Associates. Our second esteemed speaker is Mr. Shubham Bazare, who is working as a software engineering specialist at Dassault Systems. So, without further ado, we'll start with the webinar. So, just in case you have joined it right now, you shall leave your email ID in the chat box so that you will redeem your participation certificate for attending the webinar itself. Also, share it with your friends who might be interested in knowing more about this exciting field. So, let's begin. Sir, database design is quite a buzz topic going around in the industry. So, my first question to both of you is what is the significance of designing database?
Uh, Good morning, everyone, and a warm welcome to each one of you. So, it's a good question. And Before going to that, let us try and understand what is a database. Why do we need a database? So, in earlier ages, we also had this requirement of storing some data. We used to store it on Excel sheets, spreadsheets, or on a notepad or anywhere else, right? But as we grew from time to time, and as we managed to um, create different systems with computer age coming in, there was a need for a more systematic and structured way of storing this data, which can be retrieved in a proper way. And that's why this database concept originated. So a database is nothing but an organized collection of a structured information or data which is typically stored electronically in a computer system, and that can be accessed and managed very easily. So what makes database design so significant? Why is it so important? Right? So if you take example of any applications, the backend part of that application stands basically on the database structure that we have built. In most of the cases, there would be scenarios where a database is not needed, or it is simply a UI or HTML application. But in most of the applications which involves data storage and transaction based processing and etc, right? So there we definitely need a good database design. And why is it important to have a scalable and maintainable database design? It is because uh, if the database is not correctly designed, right, and you have to make many changes to the existing design whenever new feature is added, so it is not a good database design, because you will have to do a lot of changes, and the maintenance cost of your application will significantly go up, along with your downtimes for the customers, etc. You also need a good database design so that its performance is well, it is highly maintainable, and the database design also, a good database design also lets you query the data in a simpler and a faster way. So these are some of the reasons for because of which we should have a very good database design in place right from the beginning. So if you take any example of uh, good applications that we regularly use, say Amazon or Flipkart, right? So they, if you guys have observed, they introduce new features every few weeks or months, but still there we never get a downtime as such, right? The application is still up and running. We get new features added, and it, those are the some of the examples of good uh, system designs or database designs, you can say. I
Yeah,
hope
thank you,
I was
Abhijit.
able to answer the question, Nidam.
Yeah, yeah, right, Abhijit
Shubham
sir.
sir, can you add on this?
Also, yeah. So, Abhijit sir already covered most of the points, and I think almost they covered all the points. And also, we got one message from the Raj. I think we can say answer to handle a lot of data at a time. So this is one of the main reason. Thank you, Raj, for your message. So to handle a lot of data is one of the reason, and also as Abhijit sir said, we need to think about the future parts, future scenarios, because we don't know what client exactly wants, what kind of requirement they can ask. So we need to think about the future scenarios. Most of the times we need to make our design in such a way that we can modify it or we can handle most of the scenarios. So this is the one of the best thing we need to consider while designing the database.
Sir, as a natural follow-up to that question, I would like to know on behalf of audience, what technical knowledge is required to design a database?
Okay, I will go for that particular question. So, as Abhijit sir already told us, we already discussed significance of designing the database. So we need to think about the technical knowledge, what kind of technical knowledge we need. So I will go in a technical terms. So first, there are many terms we should know, like what are tables, columns, tuple, primary keys, foreign keys, what is indexing, what is normalization. So for now, I will focus on some of the terms like primary key, foreign key, normalization, and indexing. So primary key is basically a unique column of that particular table. Let's say we go with an example. Let's say so we have a employee table and we know that employee ID is unique. So we can make it primary key because we can get that particular data with employee ID. So it is unique. So this is the first thing we should consider. So while considering, while creating a table or while creating any mm, database, we need to first finalize the things which can be a primary key, which can be unique, like that. Next thing is a foreign key. Foreign key is basically used to create a relation between two tables. Again, consider our employee example. So let's say if we want to add the department, the employee belongs to some department. So for that thing, we can add department ID in our employee table. So we can avoid data duplication, data redundancy. So in that case, we can use a foreign key. Normalization, it is one of the important thing you should consider while designing a database. Normalization is basically, it is a process to eliminate data redundancy and to enhance data integrity in the table. It is a multi-step process and it consists of 1NF, 2NF, 3NF, and 3.5NF, which is also known as BCNF. If we followed normalization process, then you can what we can say, your database design, if you are satisfying these rules 1NF, 2NF, 3NF, then your database design will handle most of the scenarios. Next thing you should know is indexing. Indexing is a way to optimize the performance of the database by minimizing the number of disk accesses required. So it is also a database structure technique which is used to quickly locate and access the data in the database. Also, there are some types of the indexing like primary indexing and secondary indexing. Also, we can use multiple columns to create an index to access the data faster.
So, moving on to the next question. So, which processes should be followed while designing a conceptual database? And it would be really great if you could share a personal experience of yours in this regard.
Yeah, so uh, if we consider the design of a any of the database, right? So it basically stands on three or four different pillars, but each of them is very much important. So before, even before we go and so it's so there is a different thought process among students and public in general, that database is something that creating database is directly going and creating tables, defining relationships between them, and then inserting data, querying the data, and that's about it. But the actual database design is not done is not that simple. It goes through a lot of processes and approvals and discussions and brainstorming. So the first point that we should be doing is we should define the purpose of the database. What are our requirements? What is the use case that we are trying to solve when we are trying to design a database? Once that is considered, and we are aware and uh, convinced that these are the particular requirements for which I need to design the database, then we should analyze the kind of data that would be put into that database. What kind of table structure or model structure we would need, what would be the relations between them, what kind of keys and primary keys and foreign keys, indexes and other things need to be defined between them. So so all these things need to be taken care of. Then we also need to define the relationships between different tables. So we can have one to one, one to many relationships, right? So all those kind of relationships need to be identified, and based on that relationship between the attributes or the tables, we need to design our database design. And then we need to keep refining and normalizing this structure, go through multiple iterations, and that's how you usually design a database. And after that, writing stored procedures and functions and actual business logic, I mean, it goes after that. But database design should follow these particular steps. Recently, not recently, it has been quite a time now that earlier only RDBMS databases were used. Now we also need to consider if our use case, uh, uh, I mean, our database design should be built in a relational database, or should we support NoSQL databases based on our use cases? Are you building a social media site? Are you building something like Facebook, Instagram, or something of that sort, or WhatsApp, or are you building a banking application which requires I mean, relational database at its core? So all these things also need to be taken into consideration before we finalize the database design, or even the type of database that we want to use. Uh, I mean, I have worked mostly around the banking applications, and I mean, there we have faced some situations where the use case. So in banks, most of you would already know, but I would still reiterate that in banking systems, usually we use the relational database models, and Oracle, for example, right? So that is a dominant database that you can see across multiple Indian and overseas banks as well. So I mean, we time to time we definitely get some use cases where we get confused within which particular database to be used. So if a transactional model is needed, then definitely RDBMS is something that is preferred. But I came across a situation in my earlier projects where it was a banking application, net banking application that we were creating. But the use case that we were trying to solve, it was not a transactional one. It was kind of a user experience case where uh, after the user logs in, he is onboarded through multiple uh, uh, systems, or I mean, pages, UI pages. And for that, this data was to be kept in a table. So the best possible way of doing it in an efficient or high performance way was through using NoSQL database like MongoDB and some others that are available in market. But uh, to keep it consistent across the net banking application and entire platform, we still preferred going with the RDBMS Oracle database. So such kind of situations will definitely come where you are convinced that a particular database fits that scenario, but due to some other organizational or platform constraints, you have to make that decision, um, if which is the best possible way going forward for you. So it's not always that straightforward that I can go ahead and pick up the database that I want, but it becomes complex as and when the application grows and the system becomes very much complex.
That was
Shubham,
really
if you
great.
want,
Sorry.
yeah, Shubham, if you
Yes,
want to
Sai.
add something.
No, no, nothing from my side.
Okay. Yeah,
Different
Nidam, go ahead.
applications and different databases. So the audience would like to know about what are and how do you choose the most optimum database?
Okay. so so earlier, I mean, most of the earlier systems or the older systems that we have, you would see that those are built in relational database, rdbms systems such as Oracle, MySQL, Postgre, or some others. Now uh, there are some other databases that are available, the NoSQL databases, which have gained a lot of popularity in last few years. So they are like document databases, then key value stores, column oriented, then graph databases. So I will explain those in brief. Then there are distributed database systems, and with the emergence of cloud applications and platforms like Amazon AWS and Azure, so there are different cloud databases as well. So uh, deciding which particular model suits you or your application and system and organization, it becomes important to understand and uh, know why this particular database was created and what is the particular use case that it can solve. So if we take an example of relational databases, so in relational databases are built, these are usually schema based, and these databases follow the acid properties. Acid properties are atomicity, consistency, isolation, and durability. So we may cover these terms in detail afterwards, but uh, so if your application needs to cater to these four properties, and you know that your data is going to be structured in a tabular format, and it's possible to have that kind of structure in place, then definitely rdbms is something that we can go ahead with. In case of NoSQL databases, we do not follow the acid properties, but we follow the base properties. So base means basically available, state, eventually consistent. So so this usually applies for a distributed database system, but and NoSQL databases are mostly used in distributed networks as well. So that is the criteria that they usually follow. Now, in NoSQL databases, we have four databases: document based, wherein we can store JSON or XML documents into the uh, uh, document format. So, for example, we have MongoDB and CouchDB. So, these databases are document based databases. Then we have key value stores, wherein a key and a value similar to what we have in the hash map. So same kind of uh, structure is followed there. Redis cache, then memcache. These are some of the examples. Column oriented databases is something which is used for analytics and big data purposes. So it provides quick searches, and insertion takes a little time. So some of the examples can be Cassandra and HBase. Other databases that come under NoSQL are the graph databases. So graph databases usually focus on relationships between the elements. So if you go for any social networking sites, right? So they usually have these graph databases implemented. So one example is Neo 4G. So these are some of the ways or types of databases that we have. In case of cloud-based databases, AWS, I have mostly worked on AWS. So some examples that I can give you around AWS databases are DynamoDB, AWS Aurora, and AWS RDS, so Relational Database Service. So these are some of the examples which are provided by uh, AWS.
Yes, Shubham sir, would you like to add something to that?
Yeah, right. Abhijit sir already explained everything in detail, but here I just want to add one more generic thing. When we go with a generic view, we have two types of databases, let's say SQL and NoSQL. So most of the people made the mistake like they goes with a current one because NoSQL is a latest one. So without considering scenarios, their application, they go with NoSQL databases instead of their application maybe and will be handled more efficiently with the SQL databases. So instead of thinking about the latest one or newer one or uh, currently growing one, you need to think about the scenarios, what application you are working on, which one will be better. So you need to think about that instead of the latest one or newer one.
That was a valuable addition, sir. Sir, my
Yeah,
next question is, we hear a lot about database partitioning. So can you please elaborate on that?
yeah. So one of the main thing that we should keep in mind is that we need to break the whole data in smaller chunks. If we are able to break it, then it is more simpler to write queries to retrieve the data from the databases. If queries are simpler, then you can get the data faster, we can say. Also, let's say we have any table which has around 20 plus columns. So, and you need to retrieve some few data. So, few data from the table. So, yeah, it is tedious task to handle all the columns every time to get a few data. So let's say if you break that particular table in smaller chunks, we can say, let's say we have some particular table which stores information about person. So it stores the information about his it stores information of the person like personal details, professional details, or any other basic name like those details. So if we break that particular table in another tables like for the personal details, we have another table. For the uh, professional details, we have another table. So we can break it in a multiple parts. So in that way, we can uh, minimize our performance. We can improve our performance of the query like that.
Okay, sir. So, further moving to a technical question that is very niche to this domain. So, sir, what is meant by atomicity and aggregation?
Okay, so as Abhijit sir already mentioned acid properties, so that A stands for atomicity. Atomicity is basically a group of database operations and it will occurs all or nothing occurs. Let's say we are performing multiple operations on the database and I'm working on that database and I'm doing major modifications in the data. And let's say Abhijit sir are also doing some operations on that particular database. And if my operations gets failed or something happens, so it can hamper another person's data, whatever he is doing or she is doing. So in that case, atomicity plays the important role. If I'm creating multiple operations on the database, it will happen all or nothing occurs. So in this way we can handle multiple data duplication or data corruption thing with the atomicity. And aggregation refers to the process by which entities are combined to form a single meaningful entity. Let's say we have counts, or we want to some make some analysis from the data. Let's say we want, let's say we have a table which stores the expenses, and we need to calculate the sum of the expenses. So this is the example of the aggregation. So to get the analysis of the data, we basically use the aggregation, and we have multiple methods for that, multiple functions for that, like getting average of data. So we can perform the average, sum, count, maximum from the column, minimum entry from the column. So in that way, aggregation helps us to get the effective data like that.
Thank you, sir, for answering. Sir, what is CAP theorem?
Okay, so and this is very interesting. So cap theorem is based on three particular parameters. So let's first try to understand what C, A, and P stands for. Right. So C stands for consistency. A stands for availability, and P stands for partition tolerance. So cap theorem is, I mean, it is to be considered in case of a distributed system. Okay, so what is meant by a distributed system? So if we take any example of a big application, okay, so whether a banking application or something like Amazon or Flipkart or WhatsApp, right? So all these applications are accessed by millions of users. Now, for these applications to run parallelly, and so the backend or the database that we need to provide, it has to be distributed. So there has to be replication, there has to be multiple nodes available for multiple requests that are coming our way, right? Uh, so in such kind of systems, we have these three are the most important or the desirable properties, you can say: consistency, availability, and partition tolerance. Now, uh, what cap theorem, let's come to that afterwards. What exactly does the cap theorem say? First, let's try to understand what is consistency in terms of a distributed database system. So consistency means that the nodes uh, that are available, right? So all those nodes will have the same copy of the replicate data available with them. Okay, so if my address details are available on node 1, uh, as Abhijit Rohit Pavilion, right? So same details have to be replicated on node 2, node 3, and they are available at the same time. So and if we try to retrieve that data from any of the nodes, we'll get the same value. So that is what we call as consistency. Availability means that each read or write operation that happens for the data, okay, so that will be processed successfully. So we will either receive a success message or an error message, but the system will always respond to every request that comes its way. So that is high availability, and that is also one of the important property that uh, distributed system should have, right? Then comes the partition tolerance. So partition tolerance means that the system will continue to run even if there is a network failure between the two nodes. So as we said, in a distributed system we have multiple nodes that are connected through network, right? Now if the network between two nodes fails, it does not mean that the entire system will fail, and this is something that is not in our control. So due to xyz reasons, this can happen, that the network between two nodes fails, but we will have 50 or 100 or more than that nodes, right? So if a connection between two nodes is failing, it does not mean that my entire system will fall apart. Okay, so that should not be the case. Now, Once we have understood these three concepts, right, let us try and see what does the cap theorem say. So cap theorem states that it is not possible to guarantee all three of these properties that we just discussed: consistency, availability, and partition tolerance. All three of them cannot be achieved at the same time in a distributed system. Okay, so only two of these can be achieved, and that's where the we have to make that uh, uh, decision that I am okay with consistency and partition tolerance. I will let go of availability, or I will handle it in a different way. So something of that sort has to be done. Now, usually in most of the systems, partition tolerance is something that we cannot let go of. So we will always want our system to function even if the network fails between two nodes. Okay, so partition tolerance is something, and that is not within our hands as well. Network may fail due to multiple reasons. It can be an earthquake or anything, or something due to internet connectivity lost, and multiple reasons can be there. So so that has to be taken care of. So our system should, in most of the cases, you can say, partition tolerance is something that we need to take care of. Now we mostly have to um, select between consistency and availability. So that is where the systems or the architects and designers juggle between how do we do achieve both consistency and availability in such a way that our system or user experience is not affected much. And that's where the cap theorem comes into picture. And cap theorem states that you can achieve only two of these. And usually the I mean, we have to I mean, select between consistency and availability. So when we have multiple nodes, so we have to replicate data across multiple nodes, right? So sometimes we have to uh, let go of consistency. So we will say that my system is 100% available, but it is not 100% consistent. As in, if I am replicating data to multiple nodes, it will take me 10 minutes, 15 minutes of time to replicate it to multiple nodes. But that is fine with me, because my, so if we take an example of Facebook, LinkedIn, or other such social media sites, so they can compromise on consistency, because if someone is posting something and it gets reflected to different people at, say, 5-10 minutes or 15 minutes of time duration, it is not going to affect that much, right? But if the system itself is not available, if people are not able to post something, then that is something that is going to affect user experience and their product as well, and different other things that they are trying to achieve, right? So so based on the applications, and if we take an example of a banking application, then there we will prefer consistency over availability. Because if I am transferring money to Saudagar, and it is debited from my account but not credited to his account, then the system is not consistent, and it will, so neither I am happy nor Saudagar is happy, and that is not something that is expected from a banking application, right? So we have to always deal with these three parameters while designing system.
Thank you so for answering. Now, I would like to ask on behalf of people who are interested in making a career in this particular profile. So, sir, what is the current employment scenario in the field of database design?
Yeah, so the overall employment scenario is quite positive and forward looking. So that is there. We have come a long way in terms of database design and system design, but uh, we also need to be make sure that we are flexible enough to learn new things and expand our horizons when it comes to database design and system design. So we have to constantly keep learning and the expectations are quite high, because if you are only a database developer or a database expert, then your area or scope of opportunities is, it becomes limited, because you will see that these days most of the developers, Java developers, Python developers, they are also able to do basic database related things, right? So if you are focusing on database, then you have to be really really expert at what you are doing, and you have to think out of the box and bring something different to the table, so that um, you are matched at par with the role that you are being offered.
Thank you, sir. So, extending over that, if one wants to make a career in database design, how can one gain exposure in this field?
Yeah, so the most important point that I would say here is you have to self learn. um, so you can, I will define, I will help define a path that we can take. Okay, so you can start with the RDBMS concepts, basic database design, and here what I mean by that is you need to design different tables, indexes, what are primary keys, foreign keys, then relationships between tables, and writing PLSQL code, complex queries. Query writing is very much important, because it is something that is needed very dominantly. And if you are able to write complex queries, understand them, then you will be able to solve performance tuning problems and other and write complex procedures and cursors and other things, right? So you can start with the RDBMS once. You can create your own system, think about it, and create a database design, revisit it, take help from your mentors or uh, uh, lecturers or your friends. And once you are confident with your RDBMS concepts, then you can definitely go for at least one of the NoSQL database like MongoDB. It is one of the most used NoSQL database, document based database, and it so learning about that will give you a different understanding of concepts. Then after that you can learn distributed database systems, how they work. So usually it is not expected from a developer to know about distributed databases and all, but um, having knowledge about that will definitely help you. How the replication works, why do we need fault tolerance, why is high availability and this cap theorem and etc is needed, right? So you need to you cannot stick yourself only to RDBMS now, right? You have to slowly grow with each passing year, or with some experience at hand. You have to grow yourself, go to different horizons, explore them, and go deep and be an expert in some of them as well. Once you have some understanding of distributed databases, then you can also go and try and seek for big data systems, HBase, Cassandra, AWS Redshift, Hadoop. So these are also, these are not directly related to RDBMS or databases, but this is something that that is being used very widely for big data systems and for our um, data analytics and research purposes. A lot of industries are using it, so that is something that we can explore. And apart from database knowledge, if we are able to learn at least one programming language like Java or Python based on your interest, so if you become interested in your big data or uh, data and analytics related field, maybe having some knowledge of Python would definitely help. And in case of RDBMS, if you are trying to be an expert at that end, then having some knowledge of Java would also help. So that is a path that you can take while working or learning or creating your own database learning journey.
Thank you, sir, for the answer. I would like to invite questions from the audience. They can either type it down in the chat box or unmute and ask the question directly. And just in case you have joined right now, you can drop in your email ID in the chat box so that you will get a certificate for attending the webinar. Meanwhile, if someone has a question, they can type it down. I want to ask a particular question which we had received beforehand. So, sir, what can you like briefly explain about what is database performance tuning?
Yeah, sure. So, database performance tuning is a broader term. So, when we have a relational database and there are millions and millions of records right into the database, then the select queries that we fire on some of the tables that has millions of records, those queries are not as efficient and as performant, right? So in those scenarios we need to perform the tuning of some of the SQL queries. We need to go and recheck if our indexes are properly applied on the specified tables. Are the joins as per expectation? What is it that we can do to optimize those queries and all, right? So that is what we do in performance tuning. So we usually perform query optimization. We improve and add indexes on tables, we increase memory, and if we are using Oracle database, then we have something called AWR report, or that is automatic workload repository, that we call. So that report gives us the database performance statistics, and we get a good amount of insights from that report, which particular procedure or query or database table is giving me performance issues, and based on that we can take some decision and fix our performance issues. So these are some of the ways in which we can improve our performance, and that's what is called as database performance tuning.
Thank you, sir, for addressing the question. So, if you have any questions, you can put it down or you can unmute the mic and ask the questions. I guess there are no more questions from the side of audience. So, thank you, Abhijit sir. Thank you, Shivam sir, for your wonderful insights. It was really an informative session, and I hope the audience would have got a better overview in the field of database design and they would be interested in pursuing this particular field. I would also like to thank the audience on behalf of Pixaflip Technologies for attending our first webinar. We are grateful for your presence. Also, stay tuned and subscribe the page of Pixaflip Technologies on LinkedIn, and also follow the page of Mr. Saudagar Bade, who is the CEO of Pixaflip Technologies, for more such updates and webinars that are coming in near future. I'm dropping in the link for both the LinkedIn ID so that you can follow it directly.
Thank you, Nidam and Saudaga, for having us.
Yeah, thank you, Abhijit, and thank you, Shubham, for co-hosting this. This was really wonderful. I'm sure audience will get to know a lot of things. Even I learned a lot of things from this webinar, and we'll make sure that this webinar will be hosted on YouTube and the link will be shared across the platforms. Thank you guys on this, like coming on weekend and helping us doing this. Thank you.
Thank you. Have a good day.
Yeah.
Yeah, thank
Thank
you.
you,
Thank
everyone.
you.
Yeah.
I have shared the
Thank you,
link. You
everyone.
can
Yeah.
follow
Right.
the page on LinkedIn itself. Thank you.